I consider that's over any j, so probability of summation over I is equal to 1 to j of my ti, okay, if this part is less than or equal to t, so then what I end up with, this should be 1 minus e to the power minus lambda t to the power j. Is it not? That is, we can use by induction to prove that this should be this part. Okay. So why I am considering these things? So because I want to consider actually that P1J. Okay. So for that, I'll try to write down in terms of my T1, T2 and so on, what it is. So now P of 1J of T, because initially it is in state 1, no, x of 0. And then I want to go at state J. This part I can think of, this is nothing but my probability of x of t is greater or equal to j given x of 0 is equal to 1 minus probability of xt greater or equal to j plus 1 given x of 0 is equal to 1. Is it not? This is nothing but what? This is Pij, this is probability of x of t is equal to j given x of 0 is equal to 1. Is it not? This is exactly this part, P1j of t. So this is probability of xt is equal to j. That means because x0 is equal to 1 already you know. That is given to you because the initial or the starting size of the population is 1. So this is the distribution actually we are looking for, no? P1j of t. So this part I have equalization, so I try to probability x is equal to j given x is equal to 1 and this part. So now this one I can write down. So in terms of my time taken t, so what it says that I know that x0 is equal to 1. So the xt is greater equal to j, number of populations which is greater equal to j. That means I can think of this is nothing but the probability of that t1 plus t2 up to plus t of j minus 1 should be less than equal to t. Is it not? And then minus probability of t1 plus t2. Similarly, this part I have t of j. This should be less than equal to t. Because what is your t1? T1 is the time taken for your stay for your size 1 to 2. Okay, or the ti is taken from I to I plus 1. So that is why I am considering it is, you know, like if you have the renewal process and then we have the relations. No, exactly that's what actually I try to write down here. Okay, so t1 plus t2 up to tj plus 1, this will be less than equal to t, and that is why that x is greater equal to j. No, this is the same meaning, and then probability of x is greater equal to j plus 1. That means this is the same as probability of t1 up to tj. This will be less equal to t. So now I have already wrote down this part. This one is nothing but 1 minus 2 minus lambda t times j minus 1. No, by this condition. Because I should be to j. So, and then minus 1 minus 2 power minus lambda t times it should be j. So this is nothing but if you take common j minus 1, what I have that 1 minus these things. So I have 1 minus 2 minus lambda t times j minus 1. So I have 1 minus 2 minus lambda t, and then I have this part minus 1 plus e to the minus lambda t. Am I right? Oh, sorry, this is just 1. No, 1, then minus 1 plus this thing. So this is nothing but e to the power minus lambda t times 1 minus e to the minus lambda t times j minus 1. Is it not? Okay, so that means what? The starting with single individual, so the population size at time t it has a geometric distribution with mean lambda t. So the conclusion, the population size t at time t as a geometric distribution with mean to the power lambda t. Okay. Okay. So now I can just made a remark. Say here I said that if your population size start with 1, okay, means initially you have the size of the population is 1, but if you start that the population size at 0 is I individuals, so then what will be the case? So then I can think of this is the I independent and identically distributed geometry random variables, is it not? And hence it may follow. So Pij of t, that means if the population size, as I say that the initially if the number of population is I, okay, so then that size at time t, I can think of it is a sum of I independent and identically distributed geometric random variables, okay, and hence the distributions for that I am denoting as Pijt, it will follow a negative binomial distribution. That actually we know that if it has a say binomial the geometric distributions, and then if you consider the independent sum, then actually it gives you the negative binomial distribution. So that means Pijt, which I can have j minus 1 to I minus 1 e to the power minus I lambda t 1 minus to the minus lambda t times j minus I for 1 less equal to I less than equal to j. This is the Pijt. So what is the probability that x of t is equal to j given x of 0 is equal to y, which is given by in this form. Okay. So that is for if the population starts with I individuals, then the distribution of your population size at time t is a negative binomial. It follows a negative binomial distribution. So in other words, Pij of t, this is given by j minus 1 to c minus I is equal to minus I times lambda t 1 minus is the minus lambda 2 minus j minus 1. Because I know this part and I can think of this one is sum of the independent and identically distributed geometric random variables. Okay, hence the distribution should be the negative binomial distribution that we have done it in your probability course. Okay, so I am using that result to get it this part. Okay, okay. So now we start with population size 1. Then I want to know what is the expected sum of the edges. Okay, so that means, okay, so expected sum of the edges. So what I'm saying that if I denote my AT, which is the edge at time t of the Euler process, starting with the single individual. Okay, this is sum of the edges at time t. Okay, so then how can think of my AT? So then AT, which is nothing but A0, if A0 is your size, is the age of your the initial edge at time t is equal to 0, then I can think of this is nothing but 0 to t x of s of d of s is no, that gives you the edge. So xs, which is the number of no population that time s. And now I'm integrating up to 0 to t. That gives you the edge, the averaging things. No, so this is basically gives you the edge. So where a0 is the edge at t is equal to 0 of the initial individual. So what is your a0? This is edge at t is equal to 0 of the initial individual. Is it not? So now I want to find out the expected, the sum of the edges at time t. So expectation of a t, this is nothing but a0 plus 0 to t, and then so this is positive and so on. So I can put the inside. So this is 0 to t expectation of x of s, which is nothing but again I know expectation over excess of ds, and now this is nothing but e to the power lambda s, the mean x of s, the mean whatever I have, because already we have seen it, because it is a geometric distribution with mean e to the power lambda t. So now whatever I have, this is a0 plus 0 to t e to the power lambda s of d of s, and hence whatever you have, this is a0 plus e to the power lambda t minus 1 by lambda. So the expected sum of the edges for a ELR process at time t, which is given by a0 plus e to the power lambda t minus 1 by lambda. Okay. Okay. Okay, so maybe I stop now. So from maybe next class, I will talk about the simple Markovian queen models. Okay, so I'll stop now. I was thinking that maybe I can give the introduction, but anyway, so I'll stop now. Any question?